Hi guys! Welcome to my class. Our topic for today is about distance on the coordinate plane. You are going to learn it here, the easy way. In case you are new to my channel, please subscribe so that you will be kept updated on the next math lesson. Then, like and share so that you can also help other students. We are going to learn today how to use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. And we are going to learn today how to use the distance formula to find the distance between 2 points on a coordinate plane. The distance formula is the distance between pairs of points in the coordinate plane. We are going to designate the ordered pair of the first point as x1 and y1, while the ordered pair of the second point is x2 and y2. And we can have the distance formula as d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let us work on this example so that you will be guided. Graph the ordered pairs 5 and negative 3 and negative 4 and 6. Then find the distance f between the 2 points. Round to the nearest tenth. Let us draw the coordinate plane so that it will be clear to you. Then let us plot the first ordered pair, which is 5 and negative 3. Then let us plot the second ordered pair, which is negative 4 and 6. Let us connect the 2 points with a straight line. We are going to use the Pythagorean theorem formula, which is c squared is equal to a squared plus b squared to find the distance f. Since we are going to use the Pythagorean theorem formula, we're going to locate the A, the side length A, which is 9 units. And the side length B is 9 units also. Consequently, we have completed all the required distances for the side lengths that we are going to use in finding the distance f. Therefore, we can substitute the units in the Pythagorean theorem formula. C squared is equal to a squared plus b squared. Accordingly, f squared is equal to 9 squared plus 9 squared. 9 squared is 81. Therefore, it will give us f squared is equal to 81 plus 81. And the answer is 162. F squared is equal to 162. We are going to apply the square root on both sides of the equation so that we can cancel out the square. Thus, we can cancel out the square root and the squared on the left side of the equation, and it will give us a square root of 162. On that account, f is equal to 12.727, or it is congruent to 12.7 if we are going to round it off to the nearest tenth. Therefore, distance f is 12.7. Accordingly, we have learned how to use the Pythagorean theorem to find the distances between 2 points on a coordinate plane. Let us now study how to use the distance formula to find the distance between 2 points on a coordinate plane. Let us work on the same problem so that you can identify the comparison. Graph the ordered pairs 5 and negative 3 and negative 4 and 6. Then find the distance f between the 2 points. Round to the nearest tenth. This time, we are going to use the distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. Let us assign the first ordered pair as x1 and y1, while the second ordered pair is x2 and y2. Then, let us substitute the assigned values on the given equation. Therefore, d is equal to square root of negative 4 minus 5 squared plus 6 minus 3 squared. Negative 4 minus 5 will give us minus 9, and 6 minus 3 will give us 9 also. Therefore, it will give us this equal to square root of minus 9 squared plus 9 squared. Negative 9 squared will give us 81, and 9 squared will also give us 81. Therefore, this equal to square root of 81 plus 81. And 81 plus 81 will give us 162. Accordingly, d is equal to square root of 162, which will give us 12.727, and if we are going to round it off to the nearest tenth, it will give us 12.7. Whether we are going to use the Pythagorean theorem formula or the distance formula, we are going to arrive on the same answer. Let us work on another example so that you can fully understand the lesson and you can practice more. Use the distance formula to find the distance between point Q with the ordered pair of 1 and 5 and point A with the ordered pair of 5 and -4. Round to the nearest tenth. Let us draw the coordinate plane so that we can plot the 2 points. Let us plot the first ordered pair, which is point Q, when x is 1, y is 5. And the second point, which is A, when x is 5, y is -4. Let us connect the 2 points with a straight line and apply the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Let us label the point Q as x1, y1 and point A as x2, y2 so that we're not going to interchange it when we are going to substitute it in the given equation. Consequently, substituting the given points in the equation, it will give us a square root of 5 minus 1 squared plus minus 4 minus 5 squared. 5 minus 1 is equal to 4 and minus 4 minus 5 is equal to minus 9. Therefore, D is equal to square root of 4 squared plus minus 9 squared. 4 squared is 16 and minus 9 squared is 81. Therefore, we are going to add 16 and 81. And it will give us 97. Accordingly, D is equal to square root of 97, which will give us 9.84. And rounding it to the nearest tenth, it will give us 9.8. It is easy, right? Correspondingly, we have met our goal for today's lesson. We have learned how to use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. And we have learned also how to use the distance formula to find the distance between 2 points on a coordinate plane. To wrap it up, in applying the Pythagorean theorem formula in finding the distance between 2 points in a coordinate plane, locate the 2 points in the coordinate plane and find the distances of the 2 side lengths. Afterwards, substitute the values of the 2 side lengths on the Pythagorean theorem formula so that you can find the distance required. Likewise, if you are going to find the distance between 2 points using the distance formula, just label the 2 points with an x1, y1 and x2, y2. Then, substitute the assigned values in the given formula so that you're not going to interchange it. And you can get the distance between 2 points using the distance formula. It is easy, right? To conclude our lesson for today, I want you to always remember what His Highness Sheikh Zayed bin Sultan Al Nahyan, may his soul rest in peace, wrote for us. Education is like a lantern which lights your way in a dark alley. Sheikh Zayed wrote and left this quote for us so that the youth will always remember the importance of education. The genuine concern of Sheikh Zayed for his nation will always remain, as this quote will handed down from generation to generation. And to encapsulate our lesson for today, I want you to always remember that life is a math equation. You cannot get the most of it if you cannot convert the negatives into positive. I do hope you have learned a lot for today's topic and you find it easy. Okay? Till next math lesson. Bye-bye!